Hi my friends, I start an animation and I want you to tell me if you like this. Take a look. You see a spring between two parts, one is fixed, another is mobile, and we have an animation of a compression spring. This is the compression spring, this is the mobile object, identical with the other. This is an assembly with a compression spring. And this is an assembly with a torsion spring. You know this very well, I suppose. It is a clothes pin. Yes? This assembly has an animation, but this doesn't have. In this tutorial we discuss about animation of both kind of springs. Let's create this assembly, which is based on dynamic simulation, as you can see. New IAM, standard IAM template, place end button 1, 2, and we place this in a special position with direction to axis Y. Constrain this face placed on this plane. Yes, apply, and axis with the Y axis. Okay, the other one is constrained with axis as you can see, placed at a certain distance from the other. Constrain 150 from this face to this face. Okay. Now, since we have this placed in position and we know where it is, I suppress this constraint. You see? Now I can move this, but I don't want to move because we go to dynamic simulation. For the moment you see that there is no any spring here. Environments, dynamic simulation, we still don't have a spring. Yes, we can add a spring here by creating a joint which is not special, not rolling, not sliding, not 2D contact, but spring damper jack. We select one point, the center of this circle, and another point of the other circle. Okay. And we see a big spring here. Why? Because this is the default spring. We have to edit that spring, which is placed at the category force joints. Double click and we place here some data 150 is already placed. We apply a stiffness here, 0.01 Newton millimeters, and we know dimensions. The radius of the spring, the future spring, is 11. The facets, you see, this was modified to use this value. Facets are because of the resolution of the spring, and we select 10, which is maximum. Turns 11. What is the wire radius? Now is 6 millimeters, which is very big. We apply 1 millimeter radius, which means 2 millimeters for the wire. Tab, and we have the real spring. Okay, good. If I apply run now, nothing happens. Why? Why nothing happens, my friends? Because we didn't apply the gravity. In this assembly, the gravity is the unique force. Since this is grounded and this is mobile. Double click, direction. I select this face, but it is not good. I use vector components, but let me copy the gravity acceleration from here. Copy, then vector components. This is the axis Y, and I place here that value. You see here the marks X, Y, Z. I don't know if this is the real direction. Now we see. I applied tab to go to another cell, and you see direction is okay, but the gravity is reverted. Yes, down, always down. I place here minus, tab again, and we have the proper situation. Okay, now we can apply run. Let's see. Oh, this is okay, but if I change the time from 1 second to 5 seconds, let's see what happens. You see, forever, here is a forever moving. Why this? Because there is no friction or damper. We discussed here about the damper. Good. Let's go back to the spring and we go to damping and we add a small value here. Take a look how small is this value. I add another 0 and 5 Newton second per millimeters. Okay, we try again to see what happens, and you can see that the movement is limited. You know that in dynamic simulation the first run is for collecting data by Inventor, and now I go back. Data are collected, they are in the storage of this software, and now we have a continuous moving. Real, natural moving. We go back with the animation, and you can save the animation by using the tool Publish Movie. You accept the name, and I don't know what codec to use, so I go to uncompressed, which means that we will find a great file. Okay, now Inventor waits for me to start the run. I start run, and the movement you see here will be placed in a movie. Let's wait for it, and I'll show you the movie. You see, each movement is collected and stored in the movie, so it has a long time to do this. Then you apply again Publish Movie to end the collection of the data. You activate the movie, and this is the result. You see, it contains the simulation player, and it is not so useful for using it. This was the movie till here. We go back, and you can save this animation by using the tool Publish Movie. This small movie has no less but 1.85 gigabytes. A good result is that we got the data for creation of this compression spring. We can do this by activating standard millimeter IM. Even if we want to create a part, we have to use IAM, the assembly. We go to Design, we go to Compression, Extension, Belleville, and Torsion are the kinds of springs. We select Compression. We have to save this document. We accept this, and we get the assembly to Compression. You see a table with data. We click on this to see the symbols for each dimension. And now we place dimensions which we know. 2 millimeters is the wire diameter, 100 is this, 11 turns or coils, and we go to the calculation. These are very large numbers. We place here 0.001. We place 0.2 Newton. We place 0.1. The outside diameter is 26, and we can apply calculate. Calculation indicates design compliance. Good. We have to select an axis. Axis must be the y-axis, and the plane, start plane, is this one. Now you see the future spring. Calculation indicates design compliance, so we have the result here. This is the result. It has everything you need, so we can create this spring, but we cannot animate it at all. We can create a torsion spring like this one very easily. Take a look here. New standard millimeters IAM, and we go to design with the formal name of design accelerator. We go to the torsion spring. You must save. Okay, I saved the assembly, and we have this dialog box. There are a lot of parameters. You can click here to see other parameters. I placed data here, diameter 1.5 millimeters of the wire, external diameter 5.3, the length 20 millimeters, and I place here small values for the forces. And okay, save that object, place it somewhere, and you see the result. You must know that there are a lot of data to make this object, all parametric. If you want to edit, please use this option, edit using design accelerator, and modify what you want. However, we want to create an animation like this, for example. How can we do this, since Inventor cannot help us in this matter? My solution is a fake, but the end justifies the means, right? This is my drawing. You see dimensions here. Radius 2.7 is also in this curve and also in the other one. All unrated curves are radius 2.7. The coil is created with the method pitch and height, where pitch is 2.6, height is 568. You see all dimensions here. So let's start. New standard millimeters IPT, this plane, circle 2.5, placed on the same vertical with the center point, and the distance is 6.5. Finish sketch, coil, pitch and height, select axis. The axis is X, and 2.6 is the pitch, and 5.68 is the height. You see, we have a starting point. This is the starting coil, and we select this face for a new sketch. This is the sketch, finish sketch, and extrude on 32 divided by 2. Okay. You see in the drawing that 32. I finished it here. Now I apply mirror for obtaining a double torsion spring. Mirror solids, not features, and the mirror plane is this one. Okay. You see that we have a double torsion spring. This is the first object we create. Let's make it real as a stainless steel object. I also apply shaded, not shaded with edges. You see edges here. Okay, okay. If I close this drawing, this model, and I come back, it will be without edges, just like this. I call this DTS mid. DTS mid, because it is in the middle. We continue by creating this contour starting from here, from the base or from the end of the coil. Not this face, but the other one. You see, we create it here and not here. Okay. Start, millimeters IPT, sketch. To be sure of continuity, we start just like before with a circle of 2.5 on the same vertical with the center point, the distance of 6.5, and a coil, as you already know, axis X, data are the same. Okay. Now I create a new sketch, this circle, finish the sketch, and we apply coil about X-axis starting from the same circle as before, but changing the number of the height of the coil to 5 millimeters and cut, my friends. Okay, now we have something like this. This is the end. This is the end. This is no, this is the end. This is the end, and this is the start. After I subtracted 2 coils. You understand? I select this face to create a new sketch. I go back. This is the sketch, and I create a plane parallel to plane through point. This is the point, but what is the plane? Let's see what is the plane. This is the plane, and this is the point. You must notice that this is not sloped but parallel with this plane. Good. We use the plane to create this wing. We call this a wing, and this is the other wing. Dimensions are here, so we can start. Sketch, F7, and we draw lines. I project this point because no, it is present here. 11, perpendicular on the base. I need to project this line perpendicular, as you can see. Then I draw an arc because I keep pressed the left button and I go somewhere. This is radius 2.7. 2.7. We continue with other lines, as you can see. One is this. I want to be tangent, it is not, no problem. I go here, then I keep pressed the left button. I continue with an arc. I go up, far away, keep pressed the left button. Now I have a tangent. The arcs are identical, equal to this first one. We apply tangent between these two. We place angles. This is $35. This is 40, and this is 70. Distance is 14.5 is this one, 70 is this, and 16 for this. We have a fully constrained sketch. Finish sketch. We have here a circle. This angle is no more useful, and we can apply sweep. Sweep, this was already selected, and Inventor waits for curves. Curves are here. This is the wing. I want to mention this arc, which is part of the coil, the part of this coil. It doesn't start from here, the wing doesn't start from here, but from the circle aligned with this circle. You'll see why, my friends. Tools, document settings, and shaded. Okay. The material is also stainless steel, and I can apply shaded to have the real situation. In order to create that fake torsion, we have to create an assembly. We place the part DTS mid, grounded at origin, and the part DTS wing. We apply constraints between the two parts. This is grounded and this is mobile. This is grounded and this is mobile. We apply mate between the axis X of the two parts. Okay, you see? Now we can rotate but also move this wing. You see that they interfere one with the other. Yes? The distance between that plane, you know the plane, and the basic plane of this is the height of the coil, 5.68. We apply constraint between this plane, you remember, with the flush 5.68 and this plane. Okay, now you see there is a combination which is okay only in this position when these two are in contact. The fake here is that the two segments of coil are interfering. we have to find the angle. We find this angle right here. We take a look at a plane here and an axis. You see in red that axis. Measure M from Monaco between this plane XY and the axis. The angle is this one, a very precise one. Copy. And now we apply that angle, constraint, angle, first solution, paste that value between this plane and we don't have the axis. Let's create that axis. It is necessary. Double click here, axis. Now you see that axis. Take a look here in red. It is placed here. Once again, now we can apply constraint between constraint of angle, first solution, value, and we select this plane and this axis. No, now I have to apply the angle between this plane because it's perpendicular. Angle, first solution, value, paste. And this plane was selected. Now I select this. You see, 18 degrees and other decimals are well placed. Okay. Now we can see here that there is a continuity even if there is an interference. The problem is that when we want to modify the angle, we have to modify also this flush. You see, we can apply drive here. The angles are 1854 and here we place 0. We have a movement between the two values. Good. This is okay. I place this here, but when we go to the other value we see a gap, and also here, because we have to simultaneously move this part to the left with a certain distance. What is that certain distance, my friends? It depends on the angle, yes? And we can make a simple calculus. We use the rule of 3. If 360 degrees corresponds to 2.6 pitch, millimeters of pitch. When the angle is this one, what is the distance we need? The formula is here. Good. On this flush, the distance is 5.68. Yes, we can apply drive to it, and we place here this value plus the expression. The expression is here, and we place copy and paste plus that value. Yes, we can verify this. Now is the first value, and now is the other value. Okay, let's see what happened here. You see, there is a small gap here. Why? Because this is at the angle and not vertical. If I double click this, not double click, drive, and I go to the other value, 0, okay, now you see perfect placement of this, but we have now to drive expressions. This is important for what we do next. To obtain the movie you saw before at the beginning of this chapter with the double torsion spring, we have to replace the two drives in their original position. Here is this value, and we started with 5.68. Yes, okay. The angle drive, we started with this, not to 0, so we place to the original position. Okay, good. We create the movie by using Environments Inventor Studio. I want you to watch my tutorials number 022 and 158 to know and to learn more about Inventor Studio. It is not so difficult, but you must be very careful. I apply new animation. I double click that new animation, and we have an animation timeline. Then we select the two drives to animate constraints. That drives are connected to some constraints, and we obtain this dialog box. we want to start from this value to 0, and we want to start it from the moment 0 and end to the 3 seconds. Okay, now you see we are in that position, 3 seconds. We can go to the beginning and we can run the movie. You see, 3 seconds and stop. We also can move this cursor to see what happens during an animation. We also can see how are the details about this animation, and you see for the angle we have 2 lines here. We go further and we apply from 0, again from 0, animate constraints. Now here is the starting value and the other is that expression plus expression. You know the expression. Start from 0 to 3 seconds. I apply OK, and you'll see that the cursor goes to 3 seconds. OK. Now we have 2 movements simultaneously. You see here, I tried to find the proper illumination. I go back and you see nothing happens here, even if the 2 are interfering one to each other. Oh, we know something now. Then I want to go back from the second 3. I stop now. I can write here 3, enter, and we are in that position. Now I want to apply the reverted movement. To do this, I apply again animate constraints from the new value to 5.68, starting from this position of 3. I go here and I apply start. You see 3 is the start position, and I place here the end position, which is 6. Okay, I solved the flash. Now I am at 6. I don't want to be at 6 but to 3, to apply the same procedure for the other drive or constraint. Animate constraint. Now I go from 0 to that angle. You know the angle 18 and so on. I place here that value at the end. Again, specify start from 3 seconds because the cursor is at 3, and we go to 6 seconds. Okay, I go to start and I apply run. We have a movement up and a movement down. That's all. Good. Now I want to multiply this because I want to double the movement. To do this, I copy this pair of movements, copy, I go to 6 and I paste that action. You see, both segments are placed here. Same for the other. I select the two, copy, then paste because we are here at the 6. Good. Now I go back, I start run, and we'll see two repeated movements. Very good. This was at the second 12. Yes. Now I think to double this, which means 24, and I change the default value of 30 seconds to 24 seconds. Then I select 1 to the 4. I hope there is not another one. Copy, paste. From this 12 we have the other movements. I also select this, copy and paste. Now we have double and they finish at 24. Very interesting. You can run now to see what happens. To create a movie from this, you have to go to render animation and select a larger screen, then output. You see it was 30 seconds, but we change it to 24. You can create a preview, no render, and you see how it looks. You must save the movie and apply OK. You see the movie. It is presented here, and you can see very rapidly how it will be. Then you find that movie as you saw at the beginning of this chapter with the double torsion springs. If you close now, you find that movie in your computer. Another problem is that you want to create also the other wing. by applying a mirror and the two drives and go back to the Inventor Studio. It is not so complicated, and I'm sure you can resolve this problem. If not, write to me in the description. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones includes the previous ones. That's all for today. Thanks for watching. Bye bye.